Now, in this lecture, we find out the length of line segment X. In the drawing, you have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have this semicircle. In addition, we know that line segment AO equals to 10 units in its length. Our mission is to find out the length of this line segment AM, that is equal to X, according to what is given as the question. So first of all, we know that AOB is a quarter circle, therefore this angle AOB equals to 90 degrees in its size. It is a right angle. In addition, side AO must be equal to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. So side AO equals to 10 units in its length, and therefore side OB must be also equal to 10 units. OB equals to 10 units. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. Okay, so OB is the diameter of this semicircle. We define the center of this semicircle, this point as P. If the diameter of this semicircle equals to 10 units, then the radius OP must be equal to 10 over 2, that is 5. So OP equals to 5 units. This is the radius of this semicircle. PB is also the radius of this semicircle, therefore it is equals to 5 units in its length. We define the length, the point of tendency of tangent AM with this semicircle. This point is Q. In the next step, we will join points Q and P together by a straight line. Point P is the center of this semicircle. Point Q is a point of the semicircle itself. This is exactly the definition of a radius. So PQ is the radius of this semicircle, therefore it is equal to 5 units in its length. Here we have rule number 1. According to rule number 1, a tangent to a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So we have here tangent AB is tangent to this circle, point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to this rule number 1. We can actually implement rule number 1 in our drawing. Why? Because in our drawing, we have the radius PQ of this semicircle that is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees in its size, according to rule number 1. We focus on this common external point, point A. Here we have rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. Here we have the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule number 2, they are equal to each other. That is to say, PA equals to PB. So we can actually implement rule number 2 in our drawing. Why? Because in our drawing, if you focus on the common external point, point A, from the common external point, point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ. But AO equals to 10, therefore AQ must be also equal to 10 units in itself, because they are equal to each other according to rule number 2. So AQ equals to 10 units in its length. In the next step, we'll extend 9/7 OB and 9/7 AN by a straight line until they touch each other. So they touch each other here at this point. We define the touching point of the extended side AM and side OB as point N. By doing this construction, we created the right big triangle, triangle AON. We focus on the right big triangle, triangle AON. We define this angle ONA as theta. And we continue to focus on the right triangle, triangle AON. In this right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees, that is the sum of the angles in any triangle. In the next step, we will focus on the right small triangle, triangle PQN. This right small triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. According to the same logic, that of the right triangle AON, that this angle equals to 90 degrees minus theta. Okay, so in the next step we'll prove that the right big triangle AON is similar to the small green triangle PQN. So I write it down. The right big triangle AON is similar to the small green right triangle PQN. So why those two right triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So this is the angle AON in the big right triangle AON. And it is equal to this angle in the green triangle, that is angle PQN. Repeat again. Angle AON in the big right triangle AON equals to angle PQN in the green triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. So if we write to angle theta as it belongs to the big right triangle AON, it will be called angle ANO. And it is equals to angle theta itself. If we relate to angle theta as it belongs to the green triangle, it will be called angle QNP. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. This is angle ONP, the big right triangle A1 and O. This is angle OAN. This is angle OAN. And it is equals to this angle in the green triangle, that's actually angle QPN. Repeat again. Angle OAN in the big right triangle AON equals to angle QPN in the green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles of the big right triangle AON are correspondingly equal to all the three angles of the small green triangle PQN. Therefore, actually proved that the big right triangle AON is similar to the small green triangle PQN according to angle similarity rule. So I write it down. The big right triangle AON is similar, this is the sign of similar, to the small green triangle QPN according to angle similarity rule. And from the fact that the big right triangle AON is similar to the small green triangle PQN, we will derive that the following relationship exists between their sides. That AO in the big right triangle AON, side AO in the big right triangle AON, over side QP in the green triangle equals to side AN in the big right triangle AON over side PN in the green triangle. Repeat again, we will derive that AO over QP equals to AN over PN, and it is also equals to side ON in the big right triangle AON over side QN in the green triangle. Repeat again, we conclude that ON AN over PN equals to ON over QN. Okay, so here side AO on the big right triangle AON equals to 10 units in its length. Side QP of the green right triangle QPN equals to 5 units in its length. So AO over QP is 10 over 5. And it is equals to AN. What is the length of side AN? From the drawing it is very easy to see that AN equals to AQ plus QN. That is to say AN equals to AQ, that is 10 plus QN. So in total AN equals to 10 plus QN. Here AN equals to 10 plus QN over PN. What is the length of this side PN? From drawing it is very easy to see that PN equals to PB plus BN. That is to say, PN equals to PB, that is 5, plus BN. So in total, PN equals to 5 plus BN. So here, PN equals to 5 plus BN. And it is equals to ON. What is the length of ON? From the drawing, it is very easy to see that ON in total equals to OP plus PB plus BN. So ON equals to OP, that is 5, plus PB, that is 5, plus BN. So in total, ON equals to 5 plus 5 plus BN. ON equals to 5 plus 5 is 10 plus BN. So in total, ON equals to 10 plus BN. Here, ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. Here 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN. And it is equals also to 10 plus BN over QN. Those two sides are equal to each other. Therefore, we create equation number 1 from those two sides that are equal to each other. So according to equation number 1, we get that 2 equals to 10 plus Qn over 5 plus Bn. This is according to equation number 1. Those two sides are also equal to each other, so we create equation number 2 from those two sides that are equal to each other. So according to equation number 2, we will get that 2 equals to 10 plus Bn over Qn. So I write it down. According to equation number 2, 2 equals to 10 plus Bn over Qn. We focus on this equation, equation number 1, and we multiply this equation, equation number 1 by 5 plus Bn. And we get that according to this equation, equation number 1, 2 times 5 plus Bn equals to Qn. Repeat again. I found out that according to equation number 1, 2 times 5 plus Bn equals to Qn. Here we'll open the brackets on this side of this equation, equation number 1, and we get that according to equation number 1, 2 times 5 is 10, plus 2 times Bn is 2Bn. This is equals to Qn. Repeat again. I have found out that according to equation number 1, Qn equals to 10 plus 2 times Bn. This is according to equation number 1. While according to equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiply this equation, equation number 2 by Qn. And we get that according to this equation, equation number 2, 2 times Qn equals to 10 plus Bn. Okay? 2 times, according to equation number 2, 2 times Qn equals to 10 plus Bn. But according to equation number 1, Qn equals to 10 plus Bn. So we can substitute Qn in this equation, equation number 2, by 10 plus 2bn. And we get that according to equation number 2, 2 times Qn, and Qn is 10 plus bn, 10 plus 2 times bn. That is equal to 10 plus bn. Here we open the brackets on this side of this equation, equation number 2, and we find out that according to equation number 2, 2 times 10 is 20, plus 2 times 2bn is 4bn, is equals to 10 plus bn. Here we subtract 10 from this equation, equation number 2, and we get that according to equation number 2, 20 minus 10 is 10, so 10 plus 4bn equals to bn. So I repeat again, according to equation number 1, according to equation number 2, we found out that according to equation number 1, we found out that 2 times 5bn equals to qn plus 10. According to equation number 1, 10, 2 times 5 plus bn equals to 10 plus qn. Here, 2 times 5 plus bn equals to 10 plus qn. So according to equation number 1, we open the brackets here. 10 equals to 10 plus 2 times bn equals to qn plus 10. Here we have 10 on both sides of the equation, so 10 will get cancelled. And we left only, according to equation number 1, 2 times bn equals to qn. Again, according to equation number 1, we found out that two times bn equals to qn. This is according to equation number 1. Again, according to equation number 1, we actually found out that qn equals to 2 times bn well, according to equation number 2, we already found out that 2 times 2 equals to 10 plus bn times qn. We multiplied the equation number 2 by qn and found out that 2 times qn equals to 10 plus bn. Again, according to equation number 2, 2 times qn equals to 10 plus bn. This is according to equation number 2, but according to equation number 1, we have already found out that qn equals to 2 times bn. Therefore, we can substitute qn in this equation, equation number 2, by 2 times bn. We'll do it now, and we get that according to equation number 2, 2 times qn. And qn, according to equation number 1, is 2 times bn. That is equals to 10 plus bn. Here we have 2 times bn is 4bn, according to equation number 2. 4 times bn equals to 10 plus bn. Here we subtract bn from this equation, equation number 2, and we get that according to equation number 2, 4 times bn minus bn is 3 times bn. This is equal to 10. Actually, we found out that according to Equation number 2. Three times Bn equals to 10. Here we divide this equation number 2 by 3. And we get that according to equation number 2, Bn equals to 10 over 3 units in its length. Bn equals to 10 over 3 units. You can write down in the original drawing that this line segment Bn equals to 10 over 3 units in its length. Well, according to equation number 1, we have already found out that 2 times Bn equals to Qn. Two times Bn equals to Qn. So Qn, according to equation number 1, Qn equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, found out that according to equation number 1, Qn equals to 20 over 3 units in its length. Qn equals to 20 over 3 units in its length. This line segment Qn equals to 20 over 3 units in its length. In the next step, we'll complete this quarter circle to a circle. So completed the quarter circle to a circle, and we'll extend line segment BO by side line until it touches the circle. And we define the touching point of the extended line segment BO with this circle as C. So here point O is the center of the circle. Point C is the point on the circle itself, therefore OC is the radius of this circle. And the radius of this circle is the same radius as the radius of the quarter circle. And we have already found out that the radius of the quarter circle equals to 10 units, therefore the radius of this circle must be also equal to 10 units in its length. We just completed this quarter circle to a circle, therefore is very clear that the circle and the quarter circle have the same radii. So the radius of the circle equals to 10 units. CO equals to 10 units in its length. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, in any circle, rule number 14 is true in any circle. If we draw two chords A, B, and C, D from the common external point, point P, then the following equation will be true. That PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So here we have in the drawing a circle, and we have the common external point, point P. From the common external point, point P, we draw two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 4 in our drawing. Why? Because in our drawing, we have the common external point, point N. From the common external point, point N, we actually have two chords inside this circle. We have chord MA, this is called MA, and we have a second chord that is also drawn from point N. The second chord is called BC. So all the requirements of rule number 14 are met. Therefore, we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So write it down. If we focus on the common external point, point N, according to rule number 14, NB times NC equals to NM times NA. Again, if you focus on the common external point, point N, you can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. First of all, we have to find out the length of this line segment NM. What is the length of line segment NM? The drawing, it is very easy to see that NM equals to Qn minus Qm. Repeat again, NM equals to Qn minus Qm. NM equals to Qn minus Qm. So Nm equals to Qn. Qn equals to 20 over 3 units in its length minus Qn. So in conclusion, we found out that the length of line segment Nm equals to 20 over 3 minus Qm. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB equals to 10 over 3 units in its length here. NC. What is the length of NC? NC or CN is the same. CN in total equals to CO plus OP plus PB plus BN. So CN equals to CO, that is 10, plus OP, that is 5, plus PB, that is also 5. So 10 plus 5 is 20, plus BN, plus 10 over 3. So in total, CN equals to 20 plus 10 over 3. CN equals to 20 plus 10 over 3. And it is equals to NM. We just found out that NM equals to, here NM equals to 20 over 3 minus QM times NA. What is the length of NA? NA or AN, it is the same. AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. So we write it down. NA equals to 10 plus 20 over 3. So we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to overcome factor of 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator of this expression we have 70 that is divided by 3 and it equals to 20 over 3 minus QM. Here we multiply minus QM by 3 and then we divide it by 3 in order to overcome a factor of 20 over 3. So here in the numerator of this expression in total we have 20 minus QM times 3 is minus 3 QM. So in total in the numerator of this expression we have 20 minus 3 QM all divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to overcome factor of 20 over 3. And we get that 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator of this expression we have 50 divided by 3. So in this equation we have on both sides of this equation in the denominator of 3 times 3, that is 9. So we'll multiply this equation by 9 in order to eliminate the denominator 9. And we get that after we eliminated 9 in this side of the equation, we left only with 10 times 70. On the other side of the equation, after we eliminated 9, we left only with 20 minus 3 QM times 50. Here we divide this equation by 10 and we get that 10 over 10 is 1, so in this side of the equation we left only with 70. On the other side of the equation we have 20 minus 3 QM times 50, and 50 over 10 is 5. So actually we found out that $70 equals to 20 minus 3 QM times 5. Here we'll open the brackets on this side of the equation and we get that 70 equals to 20 times 5 is 100 minus 3 qm times 5 is minus 15 qm. So actually in conclusion, found out that 70 equals to 100 minus 15 qm. Here we subtract 70 from this equation, and you get 70 minus 70 is 0. This equals to 100 minus 70 is 30 minus 15 qm. Here we add 15 qm to this equation, and we get that 15 qm equals to 30. Here we divide this equation by 15, and finally we get that qm equals to 30 over 15 is 2. So qm equals to 2 units in its length. If this line segment qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to x according to what is given as the question. So we have to find out the length of line segment AM, that is equal to x. From the drawing, it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AM equals to AQ plus QM. So AM equals to AQ. AQ is 10 plus QM. We just now found out that QM equals to 2. So in total, AM equals to 10 plus 2, that is 12. So actually found out that x is equals to AM equals to 12 units in its length. And that is the answer to the question. I'll repeat again. This line segment AM that is equal to x according to what is given in the question is equals to 12 units. Okay, so in the next step I'll summarize the lecture. In this lecture, I found out the length of this line segment AM is equal to x according to what is given as the question. So in the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. In addition, we know that line segment AO equals to 10 units in its length. Again, our mission is to find out the length of this line segment AM that is equal to x. So, first of all, we know that AOB is a quarter circle according to what is given in the question. Therefore, this angle AOB must be a right angle. That is to say, it must be equal to 90 degrees. And also AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But it is given us the question that AO equals to 10 units in its length. Therefore, OB, it is also the radius of this quarter circle, must be also equal to 10 units in its length. Here, OB equals to 10 units in its length. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. OB is also the diameter of this semicircle. We define the center of this semicircle as P. Therefore, the radius OP of the semicircle must be equal to the diameter that is 10 over 2. 10 over 2 is 5. So the radius OP of the semicircle equals to 5 units in its length. The radius PB must be also equal to 5 units in its length. We define the point of tendency of tangent AM with this semicircle, this point as Q. Then we join points P and Q together by a straight line. Point P is the center of the circle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle. We have the radius PQ that is drawn to point Q, that is the point of tendency AM with this circle, and whenever a radius that is drawn to the point of tendency, then this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees according to rule number 1. Then we focus on the common external point A. From the common external point A, we have two tangents to this semicircle. We have tangent AO and tangent AQ, and according to rule number 2, they must be equal to each other. That is to say, AO equals to AQ, but AO is 10, therefore AQ must be also equal to 10 units in its length. Then we extended line segment AM and line segment OB by a straight line until they touch each other. This is their touching point. This is the touching point of the extended line segment AM and the extended line segment OB. We define their touching point as N. By doing this construction, we created here the right wing triangle, triangle AON. In the right wing triangle AON, we define this again as theta. So we continue to focus on the right triangle AON. On the right triangle AON, this angle equals to theta according to our definition. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. According to the same logic, if you focus on the green right triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we prove that the right big triangle AON is similar to the small green triangle QPN. Why those two right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the triangles in the right big triangle AON are correspondingly equal to all the triangles in the green triangle QPN. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5. AN, what is the enough of AN? From the law, it is very easy to see that AN equals to AM plus MN. Again, AN equals to AQ plus QN. AN equals to AQ plus QN. AQ is 10 plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the enough of PN? From the law, it is very easy to say that PN in total equals to 5 plus PN. PN equals to 5 plus PN. Here, PN equals to 5 plus PN, and it is equals to ON. What is the enough of ON? From the law, it is very easy to see that ON in total equals to 5 plus 5 plus BN. So ON equals to 5 plus 5 plus, that is 10 plus BN. So in total, ON equals to 10 plus BN. Here, ON in total equals to 10 plus BN over QN. QN is the missing sign, so we leave it as it is. 10 over 5 is 2, so 2 equals to 10 plus QN over 5 plus BN. And it is also equals to 10 plus BN over QN. Those two sides are equal to each other, so we get the equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. This is equation number 1. Then those two sides are also equal to each other, so we get the equation number 2 from those two sides that are equal to each other. According to equation number 2, 2 equals to 10 plus BN over QN. So again, according to equation number 2, 2 equals to 10 plus BN over QN. we multiplied equation number 1 by 5 plus bn and found out that 2 times 5 plus bn equals to, here we have equation number 1. According to equation number 1, 2 equals to 10 plus qn over 5 plus bn. We multiplied this equation number 1 by 5 plus bn and found out actually that 2 times 5 plus bn equals to 10 plus qn. Again, actually found out that 2 times 5 plus bn equals to 10 plus qn. And then we opened the brackets of this side of equation number 1 and found out that 2 times 5 is 10, so 10 plus 2 times bn is 2bn equals to qn. qn plus 10. Okay? So here we have 10 on both sides of the equation, so 10 we get cancelled. After we cancel 10, we left only with qn, that is equals to 2 times bn. qn equals to 2 times bn. This is according to equation number 1. While according to equation number 2, we have already found out that 2 equals to 10 plus bn over qn. Here we multiplied this equation number 2 by qn, and finally we found out that 2 times qn equals to 10 plus bn. This is according to equation number 2, while according to equation number 1, we have found out that qn equals to 2 times bn. Therefore, we can substitute qn in this equation number 2 by 2 times bn, because qn equals to 2 times bn. We did it and found out that 2 times qn, it is 2 times bn, it is 2 times 2bn, here qn equals to 2 times bn, so we substitute qn by 2 times bn. And found out that 2 times 2bn equals to 10 plus bn. 2 times 2bn is 4bn, so 4bn equals to 10 plus bn. Here we subtracted bn from this equation number 2, and found out that 4 times bn minus bn is 3 times bn, so 3 times bn equals to 10 plus bn. Here 3 times bn equals to 10. So we subtract bn, we left only with 3 times bn, that's equal to 10. Repeat again. We found out that 3 times bn equals to 10. We divided this equation number 2 by 3, and finally found out that bn equals to 10 over 3 units in its length. Here, 9 segment bn equals to 10 over 3 units in its length. This is according to equation number 2, while according to equation number 1, we have already found out that 2 times bn equals to qn, or qn equals to 2 times bn. So qn equals to 2 times bn, and bn is 10 over 3, so it is 2 times 10 over 3. 2 times 10 over 3 is 20 over 3, so we conclude found out that qn equals to 20 over 3 units in its length. This line segment qn equals to 20 over 3 units in its length. Okay, then we completed this quarter circle to a circle, and we extended line segment BO by a straight line until it touches the circle. Here we define the touching point of the extended line segment BO with this circle is C. So here we have point O is the center of the circle, point C is the point on the circle itself. Therefore OC is the radius of this circle, that is equal to 10 units, while the radius of the circle and the radius of the semicircle are the same, because we actually extended the quarter circle by a circle. Therefore they must have, we completed the quarter circle to a circle. Therefore it is very clear that the quarter circle and the circle have the same radii. That is to say, the radius of this circle must be also equal to 10 units in its length, exactly as the radius of the quarter circle, that is equal to 10 units in its length. Then I presented to you all number 14, and we implemented all number 14 in our drawing. According to all number 14, in any circle, if you draw two chords A, B, and C, D inside the circle, from the common start point P, then the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. can actually implement rule number 14 in our drawing, because in our drawing we have the common external point N. From the common external point N, we have two chords inside this circle. We have chord MA and chord BC. Therefore, all the requirements of rule number 14 are met. Therefore, we can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again. According to rule number 14, NB times NC equals to NM times NA. We have to find out the length of line segment NM. The length of this line segment NM. From the drawings, it's very easy to see that NM equals to QN minus QM. Again, NM equals to QN minus QM. NM equals to QN minus QM. QN is 20 over 3. So NM in total equals to 20 over 3 minus QM. Now we turn to rule number 14. According to rule number 14, we already found out that NB times NC equals to NM times NA. NB is 10 over 3 times NC. What is the length of, here NB is 10 over 3. What is the length of NC or CN? It is the same. CN in total equals to 10 plus 5 plus 5, that is 20, plus BM, that is 10 over 3. So in total, CN equals to 20 plus 10 over 3. Repeat again, CN equals to 20 plus 10 over 3. And it is equals to NB. What is the length of NB? NB from the drawings is very easy to see. And it is equals to NM. NM is 20 over 3 minus QM times NA. What is the length of NA? From the drawings is very easy to see that NA is AN. AN equals to 10 plus 20 over 3. Yeah. NA equals to 10 plus 20 over 3. So we found out that 10 over 3 times 20 plus 10 over 3. We multiplied 20 by 3, and then we divided by 3 in order to overcome factor with 10 over 3. 20 times 3 is 60, and 60 plus 10 is 70, divided by 3. And it is equals to 20 over 3 minus QM. We multiplied QM by 3, and then we divided by 3 in order to overcome factor with 20 over 3. So in total, in the numerator of this expression, we have 20 minus QM times 3 is minus 3 QM. So in total, in the numerator, we have 20 minus 3 QM divided by 3 times 20 plus times 10 plus 20 over 3. You multiply 10 by 3, and then you divided by 3 in order to overcome factor with 20 over 3. 10 times 3 is 30, and 30 plus 20 is 50. So in total, the numerator of this expression we have 50 divided by 3. Here on both sides of the equation, in the denominator we have 3 times 3, that is 9. Therefore, multiply this equation by 9 in order to eliminate the denominator 9. After we multiply the equation by 9, in this side of the equation we left only with 10 times 70. That equals to 20 minus 3 QM times 50. Here we multiplied, we divided this equation by 10. So 10 over 10 is 1, so in this side of the equation we have to leave 70. And here we have 20 minus 3 QM times 50. So 50 over 10 is 5. So in total, I can find out that 70 equals to 20 minus 3 QM times 5. Here we open the brackets on this side of the equation. We found out that 70 equals to 20 times 5 is 100, and minus 3 QM times 50 is minus 15 QM. So we found out that 70 equals to 100 minus 15 QM. Here we subtracted 70 from this equation. We found out that 70 minus 70 is 0, so 0 equals to 100 minus 70 is 30. So in total 0 equals to 30 minus 15 QM. Here we added 15 QM to this equation, and finally found out that 15 QM equals to 30. Here we divided this equation by 15, and finally found out that QM equals to 2 units in length. This line segment QM equals to 2 units in length. Our mission is to find out the length from this line segment AM, that is equal to x according to what is given as the question. Again, our mission is to find out the length of line segment AM, that is equal to x. From the drawings, it's very easy to see that AM in total equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. So we actually found out that X that is equal to AM equals to 12 units in its length. Okay, thank you very much.